will be Edward Price at 15:30, and then it's this one, Harold needs to find us. Please come out. What beer did you bring? Okay, so it's all good, you, John? Great.
Hello, everyone. If I start talking quietly and you can't hear me, just yell, and I'll start speaking loudly again. So I'm just going to try and give a quick snapshot of kind of where we are, where we're going with open source graphics support on the ATI side. Okay, so let's see. The things everybody kind of knows first. Some months back, we put out the first specs for the display mode setting part for 5XX and 6XX parts. First docs we put out were for the desktop chips. It turned out they were missing a lot of the interesting blocks, so we replaced most of them with the mobile specs, which turned out to have all those blocks in them. Anybody who's looking at the documents, just read the mobile ones, don't bother with the desktop ones, we left them up there. But the mobile ones are kind of all you need. Going forward, starting with, I guess, internally we call them the 620 to 635, and externally they're the 34, 53, 36, 70 or something. The display controller there changes a fair amount. My guess is Expert will talk about that a bit. That's really to support DisplayPort. Big thing there is DisplayPort puts another set of clocks and packets in between the ins and the outs, and so we had to restructure the way we abstract the blocks to let you deal with all the different clock rates stacked on top of each other. So that all changes, and Luke's cursing it, and everybody's working through. So we should get documentation out for that soon. Radon HD guys have got it today, and it was just recently, and they're working away on that. There are more changes coming down the pipe. They shouldn't be as drastic as the changes from the previous 6XX parts to the 620 and 635. But there's, I think, 2 more generations of display controller coming down the pipe with more changes in that area. So we're trying to kind of find a good way to provide direction without blabbing out, here's what all our unreleased parts do. So we're working on that. We've got DisplayPort chip support in the chips, but there's not much out there in the way of displays except for that big Dell monitor. And everybody's still figuring out how to do the DisplayPort certification. What's actually happening is we wrote some internal tools that we use for our own development. There's third-party tools that are supposed to be out for certification of the DisplayPort interfaces, and they're not on the market yet. So everyone's calling us up and, hi, can we have your internal tools? We're going, so we're cleaning those up and getting them out too. So anyways, DisplayPort is there. What we're focusing on right now is just for the new chips, getting the existing display functionality, the analog, the DVI, HDMI, that kind of stuff, getting that working. And then we'll go back and do DisplayPort as a next step after that. So 2D acceleration, it really hasn't changed since the R200 days. The programming model, even the performance hasn't changed all that much. Memory buses are wider and stuff, but fundamentally it hasn't changed. So we're not planning on doing more documentation there. I am trying to get the old R200 programming guide re-released because it's a nice intro to how it all works. There's also some information in the 3D docs that we put out last night. It's got all the command packet formats and all that junk. So the kind of the details of what you need, a lot of them are covered in the new docs we put out last night. But the old programming guide is a nice way to kind of pick up and learn how it operates and how you use it. So I'm going to try and re-release that. Starting with the R6XX parts, we actually took out the 2D engine. So there's historically been 2 ways to program the 2D engine. One is MMIO by punching registers to make it do things, and one is through the command processor where you put in command packets, the chip DMAs them up, and picks them apart and executes them. On the 6XX parts and under the 780, which is the new DX10 integrated part we just got coming out, there's no 2D hardware, but as long as you use command processor programming for the 2D engine, the command processor will interpret those command packets on the 3D engine. So if it works on 5XX, it pretty much works on 6XX. There's a couple packets we dropped, but as far as we can see, we don't use them in the open source driver. Having said that, I'm sure there'll be gotchas. The other trick, and this is what the T-Core stuff is going to be useful for, you need to set up a buffer full of commands, which basically put the 3D engine in a known state, and whenever the command processor starts processing 2D packets, it fires off this command buffer, resets the 3D engine, and it's about 3 pages of commands. And it just puts the 3D engine back in a known state. Past the 780, 2D is gone. Okay? No hardware and no emulation. So the emulation is a good, quick, and dirty way to get running today on the current parts. But going forward past that, 2D's gone. It doesn't really matter because if you look at the 2D acceleration things that actually do anything, they all use the 3D engine anyways. More than half X, it needs a 3D engine, and basically the stuff that anybody uses is 3D. So nobody really cares about 2D anymore. We need it in there for some apps, but it's one of the things where we're thinking quick and dirty is the way to go. Okay, 3D docs for 5XX came out last night. 6XX we're working on. My guess is a month, roughly. T-Core, we can clean up. What T-Core is, just so I have some free advice for any other hardware vendors thinking in the open source field. If somebody offers you an internal utility and says, here, it'll be easy to clean up and it'll be useful to developers and it won't take you any time to clean up, run. We've been cleaning this thing up for like months now. And honestly, if it wasn't for the amount of work we put into cleaning it up, I probably wouldn't bother releasing it. The real value of T-Core that we don't have covered any other way today is it covers memory manager setup that we need for DRM. It covers ring buffer setup, both for the command processor and the IDCT engine. And it's got some other useful examples. Even in the early days, I think the Radeon HD guys probably took 2 weeks to get past the point where all the stuff in T-Core was already running. So, anyways, we probably won't release it. If the lack of T-Core holds things up by more than a day, we'll just strip out the stuff we need for 5XX DRM and push it out separately. I'm determined to release it just because we spent so long on it. We're considering sample code. Yeah, I talked before, I think at XDS, the plan we were looking at was not so much documentation and more sample code on the 3D side. We're still thinking about sample code, but right now the sample code is about 6 times as big as the driver we're trying to show you how to modify. So, not sure there. We're not starting to think there's sample code. Initially we thought it would be quite hard to get documentation out the door, the sort of programming guide type documentation. When we actually went through and tried to do it, it worked out better than we expected, so, and Keith, I guess you found the same. Yeah.
Well, actually, we had thousands of pages of documentation.
Yep.
Great at the time.
Oh, exactly, yeah. Okay, so, and the main point, in case anybody's asking, why does documentation not all come out of the binder? Our development model, we've been kind of divided into different groups that work on different components of the chip for a long time. And we decided a long time ago that the first thing we needed to focus on for engineering documentation was making sure the hardware design itself was well documented and the software design itself was well documented. And then we just co-locate the hardware and software people who are working on any given block. They sit in the same office, their cubicles are interleaved, and we hope they talk to each other. And it generally seems to work. What it means, though, is if you we got hardware here and software here, you got documentation here, you got documentation here, but you don't have a lot of documentation required at the interface between the two, because we did it into groups. So as we get more geographically dispersed, and I'm guessing you guys have already had to deal with this, documentation between the hardware and software groups is becoming more important. So,
Practically, it's part of it.
yeah. Yeah, there's so many good arguments for both, and I still don't know which is best.
Yeah, I know.
But one produces documentation and one doesn't. So there's an argument for that. So anyways, we've tweaked our software processes, so the material that we need to make good open source driver documentation should be easier to come out. We're looking at making tweaks on the hardware processes as well, but they haven't happened yet, but they're in discussion. And of course, what everybody wants, the software people would like the hardware people to produce a nice programming guide. And we'll see how that works. Okay, driver status. Radeon HD supports mode setting on 5XX and up. 620, 635, and 780 are in process. They've all got the new display controller. So it's a bunch of work getting any one of them running. Once one of them is running, getting the others running should be pretty straightforward. Most MMIO-based 2D acceleration is in. And so the next thing is just getting CPD-DR support in, and then all the 3D stuff should just come up. So initial support for the new display controller, I already said this. Anyways, the existing interface is not DisplayPort. Having said that, the way it's looking, by the time we've got everything figured out enough to do the existing interfaces, DisplayPort should be easy. So, still finding surprises with existing products, and just the example here is just, I think the last week or two, we've had like 1 million emails back and forth. There's another block that we believe nobody was using on the chip, another display output block, and we found about half the 690 motherboards actually use this block. So there was a lot of head scratching all around. And the block controls are all sort of interleaved, so if you program this block, that block almost works. So anyways, we think we'll pass it now. I think Alex figured it out last night. The existing Radeon driver went up to 4XX, picked up Atom BIOS support, so that gives it 5XX, 6XX support, and it lets it leverage some of the existing acceleration code. So sort of today, 2D, 3D work is really happening more on Radeon than Radeon HD. Should catch up very quickly. Alex has textured video running on 3XX, so it looks like moving that to 5XX, 6XX should be pretty easy. It's basically just processing all the shaders. Oh, actually, that's one thing I should mention. Talking to end users of the HF products, and from all the emails that come out of Intel, I think they've got the same challenge there. There was a shift from having a lot of video processing hardware in the overlay to doing more of it with shaders. And so in our case, basically, everything up to 4XX has the old video processing hardware, the overlay with the video processing in it. Everything 5XX and up, XV is handled in shaders. And it's what, 945, 965? Okay.
Oh crap, we don't have power.
We have similar discussions.
It's a funny thing, it's just about that. They put up the 165, did on that 165 here. Why don't you use that?
Yeah. Yeah, I think we're all pretty much, I think the whole industry pretty much took all the same blocks out about the same time. So exactly, yeah. I mean, you can do so much more with the 3D. So, okay, so that's pretty much it for that. So, basic here, I think everybody knows this, but fundamentally, all the focus and all the attention is being here. I think for the next month or two, you're going to see more of the focus shift to here, which is really the 3D side, and 2D commands going down through here as well. One of the things that gets difficult explaining to someone who's new to the Linux world is half of what they call 2D acceleration runs on the 3D engine. And first time around, that's kind of hard, so I need a lot of slides. I gave up. I tried to hook the video player into all the right paths, and I gave up. So anyways. The main point here is there have been multiple X drivers over the last while, Radeon HD and Radeon being the main ones. We don't want multiple here. Okay, so one driver is good. Hey, anyways. Mode setting hardware was all new for the 5XX. So the different views of how best to handle that. My personal feeling is that having multiple drivers right now is a good thing. I think everybody agrees we need to get to one code base. But right now, I'm seeing useful things. I'm seeing different approaches work better different ways, information flows back and forth. I'm thinking in the next few months that stops being useful, but, you know, I don't know what the timing is, so probably at XTC later when we get any hack about it. So the mode setting's all new starting with 5XX. The rest of the hardware doesn't change as much. There are big changes, but they're not at the same point in the evolution. So we want to try to avoid forking the rest of the code. So basically, mode setting, there's multiple implementations today. 2D and video acceleration, or would be multiple copies of it, but we'd like to keep the code as close as possible, so it only kind of has to be supported once. If it gets fixed here, it can get fixed somewhere else. 3D and DRM, they're separate components from day one. Let's do it with one implementation. So as we get more complexity going into the drivers, regressions are going to start to be more of an issue. We're setting up build and test and working out with everybody, but we're putting in resources to do some build and test on this. One of the things that I think we found from our own internal development activities is it's a whole lot easier to fix a regression if somebody can say, this change broke it. If all you get is, this doesn't work anymore, well, did it ever work? I don't know. That's a lot harder. We use Atom BIOS internally, and all our closed source drivers leverage Atom BIOS. So when we ask questions internally in our design groups, the answers all come back couched in terms of do this in Atom BIOS. So Alex works out new stuff in Atom BIOS, and what that means is that sometimes things can pop up in Radeon faster than Radeon HD, and we're talking about ways to avoid that. Don't read too much into that. Okay, so here's the picture. This is where the display controller changes. 3D engine changes here and here. You know, different pieces change at different points along the pipe. So one of the good things is there are multiple components, so you can have multiple implementations here and single implementations there. Unfortunately, the chunking of functionality into components does not match the way that we evolve functionality in the chips. So there's always going to be stress there. And again, the challenge is always the X driver, because it's got so many different functions clumped into one block of code. So I won't go through this in a whole lot of detail, but fundamentally, between 4XX and 5XX, that's where this is a big change in the display controller. This is a smaller but annoying change. Like this changed 2,000 registers, this changes 300 registers, and then we change another 100 or something here. So the changes are back to being small. This is the most dramatic one. The big change on the 3D side, though, was between the 5XX and the 6XX. Notice I've drawn the 690 back here because it's a transition part. It's a display controller from the 5XX, and it's the acceleration hardware in 3D. You know, I didn't even draw the block between the 4XX and 5XX. There are changes there, but they're relatively minor. I'll talk about it in a bit. So fundamentally, 3D engine doesn't change all that much up to 5XX. 6XX is where it changes. It's all unified shader at that point on. The programming model does not... A question?
Yeah. Any plans to release a 3D implementation for 2XX?
Yeah, so the two parts to the answer. We had an old programming guide in DDK. Oh, yeah. Sorry. Yeah. So the question was 3D documentation for the 2XX. And so the answer there is, I'll do it in two parts. One is we had programming guides and DDK information, which covered a good part of the 2XX functionality, but did not cover the programmable vertex shader, for example. So first thing I'm going to do is re-relay. We're trying to find an editable copy of the document. It was a lot of years ago.
Well, for example, this machine has 250, and it's not supported by the official self-source driver anymore. So I can't get 3D on this machine.
Yeah. So we're going to provide more information. Alex Dyker is working for us. He's got full access into all the hardware databases. But once you get back before the 3XX, it becomes harder to find. So anyways, so quick answer is for the documentation we already have, which is everything except the programmable vertex shader part, we're going to re-release that for sure. I'm just hoping that I don't have to like take things over and put it scan it. Anyways, I'm not sure whether to. My guess is actually that the documentation we're releasing for the 3XX and up will probably be enough to figure out the 2XX programmable vertex shaders. Because there was really an overlap here. The 2XX actually had fixed function and kind of the first generation programmable vertex shaders. 3XX, we took away the fixed function and beefed up the programmable part. So I'm not sure. Having said that, the open source drivers only use fixed function today. So probably the short answer is yes. It's going to depend a bit on how quickly we can find an editable copy of the document. So I'm not going to guess on time, but it should be relatively soon.
Like you have OCR.
Sorry?
Oh, like you have OCR.
Oh yeah, then someone's got to tell us that. And it always ends up being me. So, while we're in I mean, worst case, like I say, if you want to, we've got an email address, GPU, driver, dev, support, whatever. If you just want to fire off an email, any questions on that, Alex has got access to all the information we've got. And basically, for the older parts, we're looking more at answering questions and fixing things. Whereas for the newer parts going forward, really 3XX and up, is we're trying to say, here's documentation. Because one of the problems we had with the documentation we did here, it's sort of a joke internally, but basically what it looks like is it took about 20 people to write the documentation and about 7 people read it. And that, again, those don't seem like the right numbers. So, okay, yes.
You have another slide how the mobility variable numbers fit into the definition.
Yeah, so basically, okay, it's always a challenge understanding our marketing numbers, but fundamentally, this is X1XX, this is H2XX, and some threes. So basically, as long as you can get back to tell you what. If you can figure out what core it is, you know, the 2XX or a 3XX or a 4XX, the hardware is the same fundamentally. We enable more functionality, we fuse stuff on and off, we test and sample for different, you know, speed versus power kind of things. But fundamentally, they program in pretty much the same way. It's just a different.
How can I find out the storage?
Pick a mailing list of choice and ask, what is this? And if nobody else answers, Alex and I will. Okay, so basically, the 3D engine changes between 5XX and 6XX, and at that point it keeps evolving, but you don't get the big wrenching changes for a while. The back-end part of video processing, I already mentioned, it's all done on the shaders nowadays anyways, basically the XD functionality. Motion comp also uses the shaders. There's dedicated hardware in there for IDCT that's been around for a while. It's been around like since before the Radeon. So it changes here in the sense that the way you program it, the way you synchronize it is different. It picks up new video formats and stuff. And it persists all the way to the end of the 6XX line. Okay? 780 is the first chip that does not have the legacy IDCT. It's looking like we should be able to open up the information on this. Motion comp is really, it's 3D engine with some specialized, put it in this mode rather than that mode, because MPEG has some different, everything from rounding, those kind of things. So fundamentally, render processing, motion comp, they're all 3D anyways. The IBCT and the newer ones for HF264VC1, they're handled in UVD. We're not sure about opening up the UVD block yet. So we're going to try, but right now I don't have a way to do that. Okay. 5XX 3D update, title is acceleration, and we're trying to make it clear it's not a total programming guide, it's the acceleration block. It's about half how to use and about half register specs. And then the how to use part is, vertex formats and how all the routing and swizzling and all that crap works. Fragment shader implementation, the hardware is totally different. So from a performance standpoint, things that make it go fast, stuff like that, they're all new on the 5XX. And the primary thing is the sequencer, the amount of threading it can handle, that's all different. Programming model is almost exactly the same. So main change is the shader, the actual shader opcodes for the fragment shader, they're loaded differently. One thing I found very confusing early on is we talked about universal shaders, which come in about the R300, where some texture processing and pixel processing is combined. Those are universal shaders. Sometimes the spelling checker corrected it to unified shaders somehow. So anyways, it's universal shaders for 5XX and back, and it's unified shaders for 6XX and up, and they both abbreviate the same way, so beware. The way we map from GPU address spaces to host address spaces, so GP guard, PCI guard, that kind of thing, that's different on the 5XX. That's the one thing with the T-Core stuff should handle. We probably need to push out separately. There's a bunch of virtual machine, context switching type stuff in some of the chips, basically using it essentially as, maybe production vehicles for the future, depending on how the standards work out. We're not using a lot of it today, and we're not proposing to support you using it either. We don't do anything to make sure it works in a production chip, so I'd strongly recommend you not try and use it. So the only part that we're really using today is the essentially like the PCI guard type functionality. So it's called per process page table in 5XX. It's got a different name, but does much the same thing in 6XX. And that's the one thing we haven't got programming information out to you yet. It's in the T-Core stuff, and people think that's so much to get up with. Anybody get time check? 3. Okay, good. That's good. Okay, so 6XX. We focused a lot on the 5XX documentation to get it out the door. So we haven't gone so far on the 6XX side. Main point there is that all the details are different, but fundamentally the programming model hasn't changed. It's still vertex buffers, indirect buffers, index buffers, all that stuff. The main point is that the blocks you twitch to have those polygons processed in a certain way are in different places. Most of the functions translate one-to-one, but you get this register instead of that register. Fundamental change, VAP, which is what a vertex assembler processor, is, this includes the vertex shader part, is replaced with the vertex grouper and tessellator, which does pretty much the same thing, but instead of doing the vertex shading inside, it lines all the stuff up and feeds it off into the unified shader block. There's a bunch of new blocks to recirculate, because typically, if you're using a geometry shader as well, you've got 3 passes through the shader block, even before you get into multipass rendering. So there's a bunch of new blocks to do that, so there's little storage areas, sort of, rather than just having a pipe where you've got vertex shaders and then pixel shaders, you've got your unified shaders, and then a bunch of storage things at the end. So it goes through once, feeds around again, might feed around a 3rd time, and then goes out to the back end into video memory. Back-end hardware changes are pretty significant, partly for more color processing capability, partly to make it go faster, partly for DX10. So one of the things that we're probably going to do is try and pick out, this is the stuff we need today, you know, for OpenGL type driver work. And we might do that, basically we might release the documentation in 2 stages. And what it's really going to be is the second stage will be what you need to write a DX10 driver. I don't know if that's high on anybody's list. Anyone? No? And the memory management changed again. Okay, power management. Most requested thing is power management. Part of the problem from what I can see is that our customers implement very nice, clever little power, fan temperature monitoring things that they only provide under Windows. So under Linux, your fan either runs wide open or it doesn't run at all. Neither is optimal. So the fan controllers differ widely across the products. There's a few standard chips, but there's like a million different ways to hook them up. And so we're trying to dig that out. We put a fan controller in, I think, starting with 630, and we're trying to get people to use that fan controller rather than something grafted on the outside. Yeah, thank you. We should compare notes. I don't think we're totally winning yet. So the most common question I get is, can you tell me how company XYZ designed this product? So the answer there is basically no.